you write this equation in the ax square plus bx plus c form. So what you do here is write this as x square minus 3x minus 9 is equal to 0. Now you compare with the standard form. Let's say 1. Comparing 1 with ax square plus bx plus c is equal to 0. We get a is equal to 1, b is equal to minus 3, and you get c is equal to minus 9. So from formula, you have x is equal to minus b plus or minus root over of b square minus 4ac by 2. We put those values is equal to minus b is minus 3, so it becomes minus b becomes minus of minus 3 plus or minus root over of b square minus 3 square minus 4. The value of a here is 1 and the value of c here is minus 9 divided by 2 into a. The value of a here is 1. So now this becomes 3 plus or minus square root of minus 3 square is 9, and there are two negative signs here, so this minus and this minus combined to give you a plus sign. 36 divided by 4 into 9 is 36 divided by 2. This becomes 3 plus or minus 36 plus 9 is 45, so this becomes square root of 45 divided by 2. Okay, now see, 45 can be prime factorized, so you can reduce it to a lower radical of a lower number. So in your rough work, this is what you're going to do. You're going to prime factorize 45 as 3 square into 5. Okay, so 3 plus or minus root over of 3 square into 5 divided by 2, which is 3 plus or minus 3 root 5 divided by 2. Now from your tables you can check the value of root 5, or you can use your division method in your rough to find out the value of root 5. So root 5, I remember root 5 to be 2.236. Okay, so this is 2.236 divided by 2. So once you put root 5 is equal to 2.236, you're going to get 3 plus or minus 6.708 divided by 2. Now you take the positive sign, find out one root. Three plus 6.708 divided by 2. So if you take the positive sign, you add a 3 and 6.708, you are going to get 9.708 divided by 2, which you can now divide easily to get 4.854. 854. Now if you see if they have told you the answer should be in two significant figures, so here I can convert 4.85 to 4.9, correct to two significant figures. Okay, now remember these two are not equal. 4.854 and 4.9 are not equal, but still I've given the equality sign here. I've given the equality sign here because I've written in brackets here. This is correct to two significant figures. Okay, next, taking negative sign, we get x is equal to 3 minus 6.708 divided by 2. Now you subtract these two, you will get minus 3.708 divided by 2. So this, if you divide now, you're going to get minus 1.854, which now when converted to two significant figures, it becomes equal to minus 1.9, correct, to two significant figures. So the conclusion is, hence the roots of the given equation, hence the roots of the given quadratic are 4.9, first root when we took the positive sign, comma, minus 1.9, correct to two significant figures. Okay, that's it. Any questions on this problem? If not, then I can proceed to the next one. Fine, so let us proceed to the next one. Next problem is x minus 18 by x is equal to 6. The given equation is x minus 18 by x is equal to 6. Okay, so let us solve this problem. First of all, we need to express this problem in the standard form, ax square plus bx plus c form. Okay, so we take the LCM and we proceed. So take the LCM x, you get x square minus 18 is equal to 6. Get x square minus 18, cross multiply, you get x square minus 18 is equal to 6x. Now you take 6x on from the right hand side to the left hand side. The sign of 6x is going to change. So you get this. Okay. Now this is the x square plus bx plus c form. Now you write comparing, let's call this 1. Comparing 1 with ax square plus bx plus c equal to 0. We get a is equal to 1, we get b is equal to minus 6, we get, and we get c is equal to minus 8. Okay, so now we use the Sridharacharya formula. Therefore x is equal to minus b plus or minus root over of b square minus 4ac by 2a. Put it in this formula. Minus b is negative, so minus of minus 6 plus or minus square root of b square minus 6 square minus 4 into a into c divided by 2 into a. This one. Okay. Now we simplify this. This becomes 6 plus or minus square root of minus 6 square is clearly plus 36. Minus, again minus and minus combined to give you a plus sign here. And 18 into 4 will give you a 72. Okay, divided by 2. Okay. Eighteen into 4 will give you a 72. So 36 plus 72 it becomes, which becomes 98 actually. Fine. We work with 98. So this is 6 plus or minus root over of 108, not 98. It becomes 108. divided by 2. Okay. Now 108 is the 3 figure. So 108 looks like it can be prime factorized. Let us, in the rough, let us prime factorize here. So this becomes 54, becomes 27. Okay, so this becomes 6 plus or minus square root of 2 square into 3 square into 3, okay, divided by 2. So now this is 6 plus or minus 2 into 3 into root 3 divided by 2, which is 6 plus or minus 6 root 3 divided by 2. Now what you can do is you can take 6 common, get 1 plus or minus root 3 divided by 2. Now you can cancel with 2. So you simply get 3 into 1 plus or minus root 3. Now you know the value of root 3 to be 1.732. So you just put the value here. You get 3 into 1 plus or minus 1.732. Okay. Now you take the positive sign. So this is 3 into 1 plus 1.732 is 2.732. Okay, so this is 6, 9, 8.196 is one root. And since you have to express this into two significant figures, so this is equal to 8.2, correct, to two significant figures. Okay, next, taking negative sign, we get x is equal to 3, 1 minus 1.732. Okay, so if you subtract 1 minus 1.732, you get 0.732. Minus 0.732. So now if you multiply these, you're going to get minus minus 2.194, which is equal to minus 2.2, correct, to two significant figures. Okay. Any questions on this problem? No questions?
No, sir.
So that finishes this problem. We'll take 2 or 3 more problems and conclude this exercise. All the variations I have covered, except that in this the difference between this problem and the other problem will be that in this problem I'm going to show you the division method, just a revision of the division method, although you may not require division method because the tables will be provided, but still I'll just give you just a small recap of the division method which I had discussed with you back in class 8. Okay, so let us do this problem. Solve the following. quadratic equations. Okay, first one is x square minus 5x minus 10 equal to 0, and this you will find the roots correct to 2 decimal places. Okay, the next one is 2x minus 1 by x equal to 7. This also you will find correct to 2 decimal places. Okay, and the third one is 5x square minus 3x minus 4 equal to 0. This you will find correct to 3 decimal places. Okay, so we'll conclude this exercise with these 3 problems, and then we'll move on to nature of roots of a quadratic equation. So we start with the first one. The given equation is x square minus 5x minus 10 equal to 0. Call this is already in standard form. We call this 1. Comparing with ax square plus bx plus c is equal to 0. We get a is equal to 1, b is equal to minus 5, and you get c is equal to minus 10. Okay, now we shall use the formula. Therefore x is equal to minus b plus or minus root over of b square minus 4ac by 2a. So minus 5 plus or minus 5 square minus 4 into a into c is minus 10 divided by 2 into 1. So this is 5 plus or minus root over of 25, and minus minus combines to give you a plus sign here. 4 into 10 is 40 divided by 2. This is equal to 5 plus or minus square root of 65 you are getting here divided by 2. Okay, now here in just for the first problem, I'll just recap the division method for you. If you remember, we have to find the roots of this up till how many decimal places? We have to find this up till 2 decimal places. So what we are going to So what we are going to do here is we are going to find out the square root of this up till 3 places of decimal. Okay, so I'll just show you the working here. So if you want to find out up till 3 decimal places, you take 3 pairs of zeros after 65. Okay, and now we are going to start the division method. So 64, which is the perfect square that is closest to 65, it is 64, and 8 into 8 is 64. So 8 into 8 is 64. Now you subtract, you get 1, and now you bring down these 2 zeros, and now you double this 8 here, okay, to get 16, and now you need to insert a digit here. Now whatever digit you insert will always be greater than 100, whether you insert 1 or whether you insert 9, it will always be greater than 100. So therefore you cannot work with this 100. So what you do is you put a decimal point here, and because you cannot work with this pair of zeros, you put a single zero in between this pair, okay, and you bring down these 2 zeros. Fine. So now what we are going to do here is we are going to double this 80. So instead of taking 16, now we are going to take, this is ignoring the decimal, this is 80, right? So now you're going to double 80 to get 160. Okay. So now we can work now. Now, if you try the digits here, the digits that are going to work here is 6, because if you multiply 1606, if you insert a 6 here, then you need to multiply 1606 with 6, because 1607 will give you a number that is higher than this one, 10,000. Okay, so you need to multiply with 6. Do you recall? Anyone who cannot recall the division method, class 8 division method? All can recall. Okay, so you insert the digit 6, and once you multiply these two, you are going to get 9,636 here. Okay, so you put here, you put 6 here, and you put 9,636, because if you try 7, you'll get a number that is greater than 10,000. That is why you took 6. Subtract these two to get 364, and now you bring down 2 more zeros. Okay, this pair you are bringing down. Okay, and now we are going to double 806. Doubling 806 will give you 1612. Okay, now we need to insert a digit after 2 here. Okay, you will see that the suitable digit is that fits here is 2. Okay, so it becomes 16,122, and since we have inserted the digit 2 here, so multiply this by 2. If you multiply this by 2, you get 32,244. Okay, so you insert the digit 2 here, and you write a 2 between these two zeros, and you get 32,244. Now, whether you want, you can subtract, or you can leave it up, because I've already got up till 3 places of decimal here. Okay, so now what we do is we put it above. Therefore, x is equal to, what had we got? 5 plus or minus root 65. So we put it here. Therefore, x is equal to 5 plus or minus 8.062 divided by, and we had in the denominator, I think we had 2. Yes, we had a 2 here. I'll put a 2 here. Okay, so taking positive sign, we get x is equal to 5 plus 8.062 divided by 2, which is 13.062 divided by 2. So now if you divide, you get 6.531. We need the answer correct to 2 decimal places. So therefore, you can write this as equal to 6.53 correct to 2 decimal places. Fine. Now we take the negative sign. Taking negative sign, we get x is equal to 5 minus 8.062 divided by 2. Okay, so now we are going to subtract these two. You'll get minus 3.062 divided by 2, which you are going to get minus 1.531, which is equal to minus 1.53 correct to 2 decimal places. Okay, so hence the roots of the given quadratic equation, hence the roots of the given quadratic are 6.53, minus 1.53
minus 1.5.
correct to 2 decimal places. Okay, Let us try and finish the third one also today, so that can complete this exercise. And next day I can start with a new exercise. This is 5x square minus 3x minus 4 is equal to 0. This is already in the form ax square plus bx plus c. We call this 1, and we compare this with the standard form. Comparing 1 with ax square plus bx plus c equal to 0. We get a is equal to 5, b is equal to minus 3, and you get c is equal to minus. Now you put it in the formula, minus b plus or minus square root b square minus 4ac by 2a is equal to minus of minus 3 plus or minus square root of b square minus 4 into a into c by 2 into 5. Simplify this. 3 plus or minus square root of 9, again minus and minus sign combined to give you a plus sign, and you have 5 into 4 20, 20 into 4 is 80 divided by 10. So this is 3 plus or minus square root of 89 you're getting here. Now 89 is a prime number actually, so you cannot prime factorize it. Okay, so you need to refer to the table directly or find out by division method. But here is a small catch that you need to find the roots up till 3 places of decimal. See, the question was you have to find the square root till 3 places of decimal. So when you have to find the square root till 3 places of decimal, you have to take the square root here up till 4 places of decimal. Okay, so if you check the tables or you're finding my division method, you will find that the square root up till 4 places of decimal here is 9.4339 divided by 10. Okay, 4 or more. If you're getting 5 places of decimal also, you can take 5 places, but not, because the question here is up to 3 places of decimal. You have to take the number of decimal places that you have to take here is 4 or more. I'm taking 4 places. You can take 5, 6, whatever you want. Okay, so taking positive sign, we get x is equal to 3 plus 9.4339 divided by 10. So this, if you add up, you'll get 12.4339 divided by 10. Since it is divided by 10, you just shift one decimal place, you get 1.24339. And you need the answer up till 3 places of decimal. So this you can write 1.243 correct to 3 places of decimal. 3 places of decimal. Okay. And now take the negative sign. Taking negative sign, we get x is equal to 3 minus 9.4339 divided by 10. So you subtract these two. You get minus 6.4339 divided by 10. And again, since it is divided by 10, you just shift one decimal place to the left to get minus 0.64339. And since you need your answer up till 3 places of decimal, you can write this as 0.643 correct to 3 places of decimal. Okay, that's it. That finishes all your problems of this exercise. Okay. Now, before completing, just one definition I'll mention and then conclude this class. That is, in your quadratic in the Sridhar Acharya formula, the roots of the roots of the quadratic ax square plus bx plus c equal to 0 are given by x is equal to minus b plus or minus root over of b square minus 4ac by 2a. You already know this, right? Now, under the radical, this expression that you have here, b square minus 4ac, this under the radical, the expression that you have is called the discriminant of the quadratic. Discriminant of the quadratic ax square plus bx plus c equal to 0 and is denoted by d, and sometimes is also denoted by delta. Okay, either of the two signs. Okay, now this delta or discriminant is very helpful in telling us what kind of roots this quadratic has, even without solving the quadratic. If you are not solving the quadratic, this discriminant will tell you whether the roots are real, whether the roots are rational also it can tell you, whether the roots are irrational it can tell you, whether the roots are complex numbers, not real numbers. Okay, it can tell you what nature of roots it has, even without solving the equation. Okay, so this is very useful. So now we are going to, in the next class, we are going to see how to test without solving a quadratic equation, how to check what kind of roots this quadratic has. This discriminant will help us in determining the nature of the roots. That is what we are going to discuss in the next class. Okay, so I will stop here for today.